Hey, good evening. It's about 8 o'clock on Tuesday, test day for the previous chapter. We are starting the new unit. Unit is chapter 8. This is what we're talking about. I told you second hour that I was going to be gone Thursday morning, so this is the video for you. Hopefully you understand it. It should be relatively easy for you. It's going to be heavy calculator driven. So please don't forget to grab one of the graphing calculators. Should be able to use this pretty easily. Okay, so let's get started. The first page, the front page of your notes, we're going to start with 8.1a. So 8.1a is what we're starting with, and we're going to talk about exponential growth and exponential decay today. All right, so the first thing, you've got a box right over here on the left-hand side, and it says has the form y equals abx, where x is an exponent. It's an exponent. That's why we call it exponential. The x is an exponent, so y equals ab to the x power, where a does not equal 0, so a does not equal 0, and b, the base b, is a positive number other than 1. So our b term is equal to or greater than, equal to a positive number other than 1, other than the number 1. Okay? And as we talk about this, we're going to see what an exponential growth graph looks like and an exponential decay graph looks like. So the first one of those, I'll come back. Exponential growth, also on this box over here, says with functions where the values of y grow as x increases. So my value y, my output, remember we talk about input and output all the time, my output, my y, is going to grow as my exponents grow. So like if it's the power of 1, y gets bigger, power 2, y gets even bigger. That is growth. So as my x's go, my y's are growing even higher. And then exponential decay function where the y values of y decreases as the x's increase. So as my x's increase here, my y's are now going down, and it's going to be going down this direction. All right? So let's take a look at the first one, exponential growth. Here are some characteristics of the graph of y equals abx, where a is greater than 0 and b is greater than 1. That's a good indication here. The graph rises from left to right. So left to right. So the graph is going to go this direction. The graph passes through the point 0a. This is really key. The point is going to go through 0 and the number or whatever a is. That makes it really easy to start graphing these. And then the graph also goes through the point 1, and then what the a times b is. So what a times b is, it goes through that point as well. So these are 2 points we can find real easy on the graph when we go to graph these. All right? And then the domain is all real. Oh my gosh, you can't write this evening. All real, I wanted to write pi. All real numbers. In my range is going to be y greater than 0. For some reason I can't write the all real letters this evening. I'm writing pi so much for geometry at this moment. So that is what we're talking about when exponential growth. And then for exponential decay, the graph falls from left to right. The graph passes through the point 0a and 1ab, so it does the same thing. And notice that the domain is all real numbers as well, and y is greater than 0. So both for exponential growth and exponential decay, both of these 3 things, going through the point 0a, 1a times b is the same. The domain being all real numbers is the same, and the range is y greater than 0 is the same for both growth and decay. All right, so let's take a look at these. Identify each as a growth or decay. So we want to identify if this is exponential growth or decay. So I look at this, and we're going to get to the point where we can see this right away, okay? We can see it right away. But for right now, I need you to be able to put into the calculator. So how would you do that? Well, if you remember, you're going to hit the y equals button, hit y equals, and go ahead and put 1/2. And how do I write 1/2 as a decimal? 0.5. And put in 0.5, has it by times 2 raised to x. So you should have 0.5 times 2 raised to the x. Hit graph, and you should see a graph that looks like this. Well, that should tell me it's exponential growth. It's growth. But let's figure out, let's find a way how we know that. Well, let's just pick some values for x. Well, I like nice, easy values when I look at this. So let's pick the values 0, 1, and 2. Well, how am I going to find that? Well, if I hit the second button and graph, it's going to pull up the table. Just find where 0 is on the table. When x is 0, y is 0.5. When x is 1, y is 1. And when x is 2, y is 2. Well, as my x's grow from 0 to 1, 1 to 2, did my y's grow? Well, yes. So this is a growth. This is a growth. Let's do this for the next one. Do the same thing. Plug it in to the calculator and figure out what you have. So as I plug it into the calculator, I'm going to find my table. And I'm going to look at it. And I have the values 0, 1, and 2 again. And if I plug a 0 in, what am I going to get for the value of y? Well, you should get the value of 2. If I plug in a 1, you should get the value of 4. And if I plug in a 2, you should get the value of 8. So did my values grow as my x's grew? Did my output, my y's, grow with my x's? Well, yes. So this is a growth as well. All right, moving on. Doing the same thing, okay? I'm going to allow you guys to do these on your own. And plug it into the calculator, see what you get. You should get a growth for this one, and you should get a decay for this one. All right? A growth and decay. I want you to see what the difference is between this and this. That's going to help you be able to decide if it's growth or decay just by looking at the equation. All right, so turn your page. Now I'm going to do the same. Here we go. Identify each as growth or decay. And how can I do that? Just by looking at the equation. What can I do? Well, I know that if my b term, which this is my b term, this 1/3 right here. Because remember, this is in the form of y equals ab raised to the x. So if I know that my b term is greater than 0, but less than 1, I'm going to have what? Well, I'm going to have decay. So if my b term, and this is where you can start solving these without having to put them in the calculator, or at least knowing what if it's a growth or a decay. If my b term is between 0 and 1, not including 1, then it's decay. If it's greater than 1, then it's growth. So looking at this one right here, f of x equals 1/4 times 3 to the x power. Remember, we're in y equals ab to the x degree. Well, my b term, what is it? Well, it's 3. Is 3 bigger than 1? Yes. So this has to be a growth. All right. Hopefully, you're going to start to see that. If you do a few of these, it should make some sense. All right. Now, evaluate each for when x is equal to -3 and x is equal to 2. So when x is equal to -3 and when x is equal to 2. So let's do that. F of -3. So I'm plugging -3 in for x. And there we go. Well, in a calculator, I can figure that out real easy. And what can I do? Well, 0.5 times 2 raised to the -3. Hit enter. I get 0.0625. Well, if I plug in, I'm going to do it in red so we can see, I want to evaluate it for +2. So +2. So 0.5 times 2 raised to the +2. That gives me 2. Well, what are we trying to find here? Well, we can be looking for if it's decay or growth. So as I look at this, when it's -3, I'm at a 0.0625. When x is 2, it's 2. So is this growth or decay? Well, it's growth. It got bigger, right? So it's growth. Now, could I have seen that just by the equation? Yes. This 2 up here is bigger than 1, so that should tell me that it's growth alone, right there. Okay? Now, look at the next one. F of x equals 3 times, inside parentheses, 1/2 raised to the x power. Well, I still want to go ahead and evaluate it for -3 and 2, but in your head right now, is this growth or decay? Well, it should be decay, right? Let's go ahead and put it up here, and let's see if we're right. I think we are, but let's see if we are, okay? And there we go. So, in my calculator, 3 times, inside parentheses, 0.5, I always like writing 0.5, raised to the -3, should be 24. Should be 24. Well, let's check it when I plug in a +2 into the equation. So 3 times 1/2 raised to the +2. So 3 times 0.5 raised to the second power is 0.75. So F of 2 is 0.75. Well, did I get bigger or smaller? Well, when x was -3, it came out to be 24. When f is +2, it came out to be 0.75. It got smaller, which means it is decay. So we've done it right. We knew when we looked at it to begin with that it was decay. All right. Next one. I have f of x equals 1/2 times 2 raised to the x power. We want to graph these. So if I look at this, let's get a couple things and let's remember a couple things. One, is this growth or decay? Well, it's going to be growth because remember this is in y equals ab to the x power form. Since this b term right here, the 2 is greater than 1, this has to be growth. That's one thing that we should know right now, okay? The second thing is to remember, we talked about this at the beginning. I'm going to put it in a different color. When x is 0, what does a or what does a y have to be? Well, it's the a term. And then when x is 1, it has to be the a times the b term. Those are two things I can find without doing much work. and it happens every single time. Okay? Well, let's do that. When x is 0, it has to be the a term. Well, what is my a term? Well, it's 1/2. So when x is 0, y has to be 1/2. When x is 1, it's a times b. Well, 1/2 times 2 is 1. So I know that I'm right here. How am I going to find the other points? Well, I can put it in the calculator and graph it. So in my calculator, y equals 0.5 raised to 2 to the x. We've already seen this. I see my graph. It's going up. I can see it. You can too. Hit second in graph, and let's find some points. 1, 1, 2, 2. Right? 2, 2. And 3, 4. 4, 8. That's about as high as I want to go that direction. Well, what's a -1? Well, -1 is at 0.25. Let's try going all the way over to like -5. Well, -5 is 0.01563. Well, you're going to notice that it's never going to reach the x-axis. It's going to get closer, 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 but it's never going to get there. So my graph is going to look like this. And that shows exponential growth. All right? Let's do the last one. Looking at this, what is my b term? My b term is 1/3. That's less than 1, greater than 0, so this is going to be a decay. When x is 0, what does y have to be? My a term, which is 2. And then when x is 1, what does my y term has to be? Well, a times b. Well, what's a times b? Well, let's get there. 2 times 1 divided by 3. 0.67 really if I round. Okay, so I know at 0 it's at 2, and at 1 it is at 0.67. So right in there. Now, how can I find the other points? Plug it in. Y equals, we are doing 2 times 1 divided by 3. I put it inside parentheses just like I have it up there. So I put 2 times inside parentheses 1 divided by 3. And I'm going to raise it to the x power. So it should look like that. Okay? Hit graph. And it does show a decay, which is what we wanted. Now hit second in graph, and it gets me some other points. Find the ones that on the table that fit. Like -1 is at 6. -2 is at 18. That's too big for us. So we've got enough points. Let's go to +4. 4 on the x is 0.02469. So it's going to be down here. So once again, it's going to get as close to the x-axis as possible and go just this direction right there. All right. Hopefully you've enjoyed this lesson. I'm going to do one more thing. I got to remind you. We talked about it briefly right after the test on Tuesday. But remember, you're going to have 6 problems. They're going to talk about linear, quadratic, and exponential. Right? Remember, linear is just like y equals 2x plus 3. The x is only raised to the 1 power, right? You don't see any power, right? When we don't write it, it's a 1. So there is no power. Quadratic would be like y equals x squared plus 3x minus 4. It's got a square term. That's quadratic. And then exponential is going to be like what we just did. Y equals a b to the x power. It's raised by the x power, okay? So quadratic raised by 2. Linear, no power up top, right? Nothing other than a 1. And then exponential raised to the x power. You're going to have 6 problems dealing with that. We'll talk about that more later, but there are 6 of them on there. All right. Enjoy your Thursday. Ask any questions that you have. I'll be back on Friday.